Hello.
Yeah, start. It's like Nandini.
Yes, sir. Yes, sir. I'm starting. Good morning, one and all present here. Good morning, one and all present here. On behalf of East Point College of Engineering and as a coordinator of webinar, I, Nandini Gowda P, the Assistant Professor, Department of ESE, would like to uh, welcome you all for the technical webinar on AWS Cloud Practitioner Essentials organized by the Department of ISE, EPCET, and it will be live on YouTube and Facebook. The EPCET is signed MOU with AWS Academy under the guidance of our principal sir, Dr. Prakash Yes, on August 2019. AWS Academy courses help the student to develop the on-demand cloud computing skills and hands-on experience on the cloud environment and to earn the industry-recognized AWS certification. Over 100 students of EPCET are trained on AWS Cloud Practitioner Essentials, and more than 10 students got certified, and more than 30 students are taking up the exam in the coming future. And now it's my privilege and honor to introduce our speaker, resource person for the day, Mr. Bhaskaran Venkataram, Manager, Learning and Development Technical at Amrita Vishwa Vidyapeetham, Coimbatore. So, we welcome you, sir.
Thank you.
Bhaskaran, sir.
Yes.
Mr. Bhaskaran sir, has 20 years of experience in various domains such as training, software development, configuration management, and sir worked in various organizations such as Ericsson, L&T, and Infosys, etc. Bhaskaran sir currently working as a manager, learning and development at Amrita Vishwa Vidyapeetham, Coimbatore since from 2016. The Bhaskaran sir did his BTech in Madras Institute of Technology at 1992 and Bhaskaran sir did his postgraduate in computer science from University of Houston, Texas, USA at 1999. The Bhaskaran sir currently working at Amrita Vishwa Vidyapeetham. He has trained more than 200 students in AWS Cloud Practitioner and Solution Architect. Around 70 students certified in AWS Cloud Practitioner and 5 students in Solution Architect. Bhaskaran sir has conducted many workshop sessions for various industries like Microsoft, Cisco, and Amazon, and he has done various workshops for the teachers also. So we welcome you, sir. We heartily welcome you, sir. It's my privilege and honor to welcome you, sir, for the session.
Thank you.
Bhaskaran, sir.
Thank you.
So, now we are pleased to welcome our Honorable CEO, Mr. Pramod Gowda, sir, and Mr. Raji Gowda, sir, for the webinar. We welcome you, sir. Now I would like to welcome our Honorable Principal, Dr. Prakash, sir, for his constant support, and he is mainly the person who has introduced us to the IALP. And we welcome you, sir. Principal, sir. Sir, Principal, sir, you are on mute.
Yeah, thank you, Nandini. Thank you so much. Very kind of you.
Thank you, sir. Our beloved principal, Dr. Prakash sir, has helped us in various events and enlightened the students and the teachers on new technologies. Now, I would like to welcome our beloved HOD, Professor Kempraju sir, for always motivating and encouraging the teachers for all the events. We welcome you, sir.
Thank you.
Okay. Now it's my privilege and honor to welcome all the registered participants from the various colleges of Karnataka and other states who have shown interest in learning the new technologies. We welcome you all for the today's webinar on AWS Cloud Practitioner Essentials, and it is from 10:30 to 12:30. Now I request our beloved HOD sir to brief about the webinar.
Yeah. Good morning once again, dear friends. At the outset, It's a great honor and privilege to host Bhaskaran sir. I know that he's a very busy man. In spite of his busy schedule, he made up the time to come and empower our student community and teaching fraternity. Thank you, Bhaskaran sir, once again for your precious time and sharing your technical expertise to my teaching fraternity and my students.
Thank you,
Sir,
sir.
Coimbatore Amrita Vidyapeetham, I think they are doing amazing industry programs for the benefit of the students, and moreover, more specifically on industry certification. You lead the complete team, and you have seen a lot of success uh, in this complete process. We also at East Point College of Engineering and Technology, we have created a separate department called as Industry Institute Integrated Learning Programs. Under this, we have included AWS Academy. We have with Salesforce. We are with UiPath. We are with VMware IT Academy. We are with ARM. We are with Cisco. We have built quite a good number of center of excellences in our college. And in this process, we are training exclusively students on industry certifications. All the students after the training program get certified on AWS. Good that I should thank Amit Rawat. Amit Rawat was heading the AWS Academy. In fact, another person from tomorrow is going to take over at the AWS Academy. He's the person who introduced me to AWS Academy. So I need to thank Amit Rawat and Vishram ji from AWS Academy for really taking us to do some good job to the student fraternity. We have already trained around 50 students. Probably in the next month's time, all these 50 students are going to give the examinations for cloud practitioner. Good that we have 3 faculties who are already certified on solution architect. It's one big thing. Uh, Looking forward, we want to get associated with Amrita Vidyapeetham and more specifically with Bhaskaran sir. Kindly help us in taking forward how to industry certification academia. Thank you so much. I congratulate Department of Information Science and Engineering, Shivali Madam, and all the team of AWS for having Professor Bhaskaran over here
Yes, sir.
to deliver the complete program here. Thank you so much once again, sir. Very nice of you.
Yeah.
Thank you, sir. Thank you so
Thank
much.
you. Yeah.
Thank you, sir. Thank you, sir. Now, thank you, sir, thank you, Principal, sir, for your valuable words. Now, I would like to request our HOD, sir, uh, to brief out the webinar.
Good morning to one and all. As a part of our webinar series, today we are arranging a webinar on AWS Cloud Practitioner Essentials by the renowned expert Bhaskaran Venkataram sir. As we all know that the resources, IT resources are available at the cloud, and nobody, even the startup companies or the very large companies that don't want to invest anything physically to take the resources. So everyone is depending on the cloud service providers. So the cloud service providers will give all kind of services, whether it may be a computation service, or it may be a storage service, or it may be a network service, or it may be a database service, like this. So now we have an honor that the AWS Amazon Web Services is the leading and the most comprehensively and broadly used cloud service platform. This is because of many reasons. So it may be cost less, it is more efficient, it is more elastic, it has given highest security, the instant access, like this. So the Amazon Web Services, I learned now, it is giving around more than 200 services in the different domains. So it may be in the artificial intelligence, machine learning, IoT, like this. So now today we are very privileged and honored that the expert person Bhaskaran Venkataram is with us. And without taking much of the time, we can listen to the technical person who is practicing the technology. So now, with this, thank you, everyone. I will move to the resource person now.
Thank you, sir. Thank you, sir. Over to you, Bhaskaran, sir.
Yeah, thank you so
Over to
much.
you, Bhaskaran, sir.
Thank you so much. And I was really, elated when Nandini madam said, can you please take a session on cloud computing? Because it is my favorite subject. And I was very happy that this knowledge can be given to students and other faculty members who are interested in learning about cloud computing. So cloud computing is a very interesting field, and there are a lot of things to learn. And definitely, if you want to take up AWS Cloud Practitioner, we will be able to provide you all the expertise, the resources required, the labs, and we will be able to share all of those details with any student that wants to take up AWS Cloud Practitioner. So I would like to thank the principal, HOD, Nandini madam, Shefali madam, and all those with whom I have been associating with for the past 1 year. So since they started cloud practitioner classes and they got certified, from that time I've been associated with them. So I would like to thank them for giving me this privilege to talk about cloud computing and to address the various cloud computing services. I would also like to thank our director, Parameshwaran sir, who has been instrumental in us getting certified and in turn train our students. We are proud to say that we have about 67 cloud practitioner students, certified students, and 5 certified solutions architect certified students. And a lot more are in the pipeline to take it. And we have also started the batch with our Bangalore campus, and Vinita madam is running that course from there, and she has got some students certified as well. So we want this to be, propagated to all colleges and branches, and we will try to do whatever we can in doing that. I would also like to thank Amit and Vishram for their continuous support and encouragement, and AWS for giving all the materials for free to the student community. They are doing a great service in taking all this to the student community because everything is provided for free, right? The labs, the course material, excellent course material, everything is provided for free. So students can learn a lot practically by doing them, right? So whenever you do things, you learn it better than reading a textbook or watching a video. So with thanking, and finally, I would like to thank all of you who have come here and who want to learn cloud computing. So with that interest in mind, all of you have joined this session. So I'm really thankful to all of you, right? With this, I will start the session, and this is going to be the agenda, what I'm going to cover. So we are going to see about the cloud computing concepts and advantages of cloud computing. So all of you need to know about cloud computing. Introduction to AWS services. Then what is AWS global infrastructure? Amazon Elastic Compute Cloud is the virtual machine that you're going to create on the cloud. So I'm going to show you a demo because the demo will be very interesting for you to see and how we create a virtual machine. What are the steps in the creation of a virtual machine? So I'm going to show you a demo of both a Linux web server as well as a Windows web server. So I'm going to show a demo of both of them. Then depending on the time, we will cover storage services and S3. S3 is simple storage service. So we will cover some basics of S3, and we will see what is the shared responsibility model. And I will give you an idea of what are the requirements to do the cloud practitioner. So the cloud practitioner is actually an awareness. It will give you an awareness on the cloud services. It is easy for any student to take and clear it, right? So they're going to just test the basic awareness of the various cloud services, and definitely students should get certified in AWS Cloud Practitioner. So if you really, put some effort on a day-to-day basis, it can take as little as just a month for you to clear the Cloud Practitioner exam. So later on, I'm going to show you details about the exam and what are the things that you need to prepare. So first, let us start with cloud computing concepts. So these are the basic cloud computing concepts overview, and this is the cloud practitioner material that AWS has provided, given us. So what is cloud computing? What are the 6 main advantages of cloud computing, and what is Amazon Web Services, right? So to explain to you simply, cloud computing is a technology which enables us to access a service through the internet. So to give you in very simple terms, that is what cloud computing is. You are accessing a service through the internet. So you will be able to access that service through the internet, and you will be paying for that service depending on the time that you are going to access that service. So it is like a utility service like electricity, right? So in electricity, depending on the amount of consumption, we are going to pay for the service. Same way, cloud computing is a technology in which you will be paying depending on the amount you use. And the other important advantage of cloud computing is it should be available on demand, right? So to give you an example, let us say that I'm working on an application. It is there in my office, and I'm from home, so I cannot connect to it through the internet. Then it is not a cloud computing service, and the difficulty I'll face is I cannot access that service at all times, right? So cloud computing is a technology which is going to give you access to that service 24/7, 365 days a year, anytime, any place, anywhere, because that service is accessible through the internet, right? And that is why it has become so very popular. So most of them are trying to shift their services from the traditional setup to the cloud. So in these slides, we are going to see about different cloud computing concepts. So what are the different types of cloud computing? What are the 6 advantages of cloud computing? And what are the cloud deployment models and AWS cloud adoption framework? So we will see some of these types. So what is cloud computing, right? Just now I mentioned what are the 3 important aspects of cloud computing. They are mainly the resources available on the internet, and the resources pay as you go, and it is going to be on demand. So that means whenever you need that resource, you will be getting that resource.
Bhaskaran sir, 1 second, sir. Bhaskaran
Yes.
sir.
Yes.
Sir, you need to present the slides, sir. Slides are not visible.
Oh, I'm sorry. I'm sorry.
Yeah, please.
Okay. Yeah.
Yeah.
Yes. Is it visible?
Yeah, kindly share the screen, sir.
Yeah.
Yes, sir.
Is it shared?
All visible, sir. Slides are visible.
Are you able to see the screen?
Yes, sir. We are able to see the screen.
Okay.
Please proceed,
So
sir.
you're able to see the on-demand via the internet and pay-as-you-go pricing. So these are the 3 important aspects of cloud computing. Now, this slide is showing an important picture to you, right? In the traditional setup, you have all your applications in your data center, right? So where you have a lot of servers and equipment like what is shown here. So that is hardware, right? You need to have storage. You need to have a big room for putting all these servers. You have to have all these racks, right? and you have all your applications running on the servers. Now this entire hardware has been transformed into a software. What do we mean by software? Now I don't have to have a big rental accommodation for my servers. I don't have manpower to manage those servers. I don't need any of the costly hardware equipment, right? The networking equipment and all those. All I will do is I will go to one of the cloud service provider like AWS, and I will, whatever service I want, I will provision that service on the cloud and I will use it. Basically, I don't need any hardware now because everything is managed by the cloud service provider. In this case, it is Amazon, right? So everything is managed by them. The hardware, the manpower to manage those servers, the rack and stack, everything is managed by them. The security, all that is taken care of by them. So all I need to do is have an account with the cloud provider. In this case, it's AWS, and then I'll be able to access that service. Now, before cloud computing, this was the case where you have to buy all the equipment. So you have to spend a lot of money in the physical infrastructure, right? But after that, after cloud computing, you don't need to invest in any of these. Just access the resource over the cloud and pay depending on how much ever you use, right? The problem with this model is it is very difficult to guess what is going to be our requirement. So most of the time, either we will have overutilization or underutilization. That means we might have bought more computing power, storage and networking than what we may need. In which case, most of the time they will be idle, right? Or it will be overutilized. That means we don't have adequate capacity, right, to require all the needs, to take care of all the needs. So this gives you an example of the issues with the traditional setup, right? We have all these problems with the traditional setup. So what if your needs change? So if your requirement is going to be more, so what is going to be the case? In that case, you have to buy new server equipment, computing resources and so on, right? So in this case, we don't have anything. If we need more resources, we can access more resources from the cloud. We can provision more number of servers, right? If we want more storage, we can again access more storage. So all those things are very possible. So your whatever requirements you have, the cloud is going to match your requirements exactly. Whereas the traditional setup, we always faced either overutilization or underutilization. So this is about the flexibility of cloud, right? Because you can access the services quickly and it will be cost effective, right? So why do we say cost effective? Because now the requirements are changing rapidly. I cannot invest in so much of hardware and it may not be required in the long term, and the technology is changing rapidly, right? Today you buy a cell phone, that model is outdated in next year, right? So we don't want to spend so much money and invest in the infrastructure, right? You have to buy all those servers, networking equipment, storage and everything. Instead, I will use the cloud resources, right? Depending on the amount of usage, I'll be charged. So that model is cheaper, right? So why do you think so many services have switched to the cloud? The reason is simple. It is cost effective, right? It is cost effective. It is fast. You can provision a virtual server in just a matter of seconds, right? So anything that you want, you can get from the cloud in very short time. And you want, you use it. If you don't want, you release the resource, right? You don't need any space, hardware, manpower, and all those things. So more and more companies are shifting to the cloud. And these are the main reasons. So these are the three models of cloud computing. Some of you may be familiar about this. We call these as infrastructure as a service, platform as a service, software as a service, right? So these are the three models of cloud computing. So what do we mean by software as a service, right? A software is provided to you, you are the user, right? So the software is available over the internet and you are the user. Example, we use so many cloud services, right, without being aware of. The Google form, the Google quiz, right, the Google Drive, Gmail, everything is examples of cloud computing, right? So your Google Drive, where you store your files, that's in the Google Cloud. So similar to Amazon, Google has got a Google Cloud platform. Microsoft has got Azure, right? So these are all, cloud vendors. AWS is one of the cloud vendors. Similarly, you have Microsoft. Microsoft is another cloud vendor, and its cloud product is called Azure. And Google has got a cloud product called Google Cloud Platform, GCP, right? So all those things are cloud services, right? It's very easy for me to use. Whenever I want to share a file, right, I will just put it in my Google Drive and send them a link, right? And they'll be able to access it. See how easy it was. What happened in the earlier days? When we wanted to send a big file, it was very difficult because it cannot be sent over email. Email had got a restriction, right? So it was very difficult. And after the advent of cloud, all these things became very, very easy. I want to share a video with my students, just put it in my Google Drive and share it, right? Otherwise, I can do it also on Microsoft OneDrive and share it. So it's very simple. So cloud platforms give us a lot of flexibility and ease of use. And these are the examples of software as a service. In the software as a service category, we are the users. The entire software is given to us, right? We are just going to use it. And in platform as a service category, to give you an example, the operating system, the platform, namely the IDE, right, integrated development environment, for you to develop applications. For example, Eclipse is an IDE. Microsoft Visual Studio is an IDE, right? So if platforms are available where users can write code and develop applications, then that model is called as platform as a service, right? The third structure is infrastructure as a service, IaaS. In this case, only the hardware and the storage and computing needs are given to you. All other things you will have to take care. That means you have to install the operating system, you have to install the applications, right? Only the hardware part is given to you in this case. That's why it's called as infrastructure as a service, right? The Amazon EC2 is a virtual machine, and I'm going to show you a demo of that in a short while, and that belongs to the category infrastructure as a service. So these are the three models of cloud computing. Then we have the cloud deployment models, all in cloud, hybrid cloud, and private cloud. So to give you an example, the one that we'll be using is a public cloud, right? That's what they mean by all in cloud, right? In a public cloud, the vendor, the cloud vendor, manages your data, right? It is going to be stored in them, in their place, right? In their servers, in their storage equipment. So that is public cloud. All in cloud is a public cloud. Private cloud is where you get all the benefits of cloud computing, like availability, fault tolerance, and all that. But that cloud is built in your data centers, right? So this is a hybrid because the data is going to be in your premises, right? It's not going to be with the cloud vendor because you are concerned about the security of the data. So you are having highly confidential data and you don't want that data to reside in the public cloud. Then you will go for the private cloud. Hybrid cloud is a mixture of public and private cloud. So what do I mean by hybrid cloud? What I mean is you can have some parts of your application, certain applications reside in the public cloud and certain things you can have it in the private cloud. So you have a mixture of public and private here. That's why it's called as hybrid cloud. So this picture is giving you the characteristics of cloud versus on-premise, right? So in the cloud, you can see that the demand, the actual demand, right, and the capacity, they are all together. I mean, depending on your actual demand, the capacity is growing, right? You're able to see it. Your demand grows, capacity grows accordingly. So there is no overutilization or underutilization of resources, right? But this is going to be on-premise. That means your applications are residing in your own data centers, and you have manpower and machines to take care of your applications. So in this case, you're able to see that this is the actual demand, right? This is actual demand. Sometimes you're provisioned more compute capacity, but your demand is only this much, right? But you're provisioned more. But at times it is under provisioned, as shown here, right? Because it's very difficult for us to forecast what is going to be the demand, right? Let's take an instance of a web server, right? So during certain, let's say we are running a retail store, and say we have some peak demands during certain festival times, right? So will it be possible for you to buy more storage server and other things during festival times, right? Which will not be used after that, say during Deepavali time, right? During Pongal. So during those festival times, you need more resources. It doesn't make sense to go buy equipment during that time, because afterwards those equipment will not be used, right? Then you don't need it. Whereas the cloud, you can provision whenever you want more, provision don't want, you can cut down on the resources, right? So the cloud is going to give you the flexibility. So all in cloud and on-premises, you're able to see what are the advantages of cloud, right? No investment, right? Because I can access all the services through the internet. So low ongoing cost, only depending on the usage I'm going to pay. You can focus on innovation, capacity, speed, and agility, and global reach on demand. That means your service can be made applicable to the entire world in a matter of minutes, right? So that is the power of the cloud. With on-premises, you have all these issues. You need to have people who administer the systems. Your capacity is going to be fixed, right? Either more or less. You are going to have large capital expenditure, right? All these are issues that you face with the current on-premises applications. So what can you do in the cloud? These are all the things that can be cloud. This is just a small subset. There are a lot more things you can do with the cloud. You can host your applications. You can store files and other material that you want in the cloud. It can be used for content delivery, right? It can be used for websites, running websites, databases, and so on. So this gives an analogy between the on-premises infrastructure and the Amazon Web Services, right? So these are the agents that are in an on-premises infrastructure, and these are the replacements when we use the Amazon Web Services, right? So we have a firewall in our network which is going to help certain kinds of traffic to enter or exit your network, right? We put what are called as rules in the firewall, and we can say block certain internet sites, right? Or see, from internal also, certain kinds of messages we can block from going to the outside world. So all those things can be done with the help of firewall, and the corresponding entity in the cloud is called as security groups. So when we do the EC2 demo, I'll be showing you how to configure a security group to allow only certain types of messages to your server, right? Similarly, you have ACLs and NACLs, and you have administrators running here. Here you are, that is replaced by a service called Identity and Access Management. Similarly, for networking, these are the current agents that are used, and they are replaced with these: Elastic Load Balancing and Amazon VPC. On-premises servers, right? They are replaced with EC2 instances, And now we are going to create EC2 instances. Storage and databases. Here you have the equivalent of storage and databases. So in AWS, each of the service is identified with the icon, right? This is a Elastic File System. This is a Amazon EC2 instance. This is Elastic Load Balancing. This Amazon S3, right? S3 is a storage service like Dropbox. You can store files, but it has got a lot of other functionality, right? If we have time, we will see a little about S3. RDS is the relational database service, right? That is available and you can utilize it to create a relational database. So there are 6 database engines that are available: MariaDB, MySQL, PostgreSQL, Oracle, SQL Server, and Aurora. So these are the 6 DB engines that are available and can be used with Amazon RDS, right? So you want storage, you will use S3, you will use EBS, EFS, and when you want database, you will use RDS. If you want server for your compute needs, you will provision EC2 instances, right? You want a network, you will create a VPC, and you want security, you will configure security groups, right? We will see all these things when I give you a demo of EC2. What are the important features of cloud computing? These 4 are extremely important: high availability, fault tolerance, scalability, and elasticity. High availability: whenever you need it, the application is available 24 hours, right? 24/7, 365 days a year. All you need to have is just an internet connection. Fault tolerance: so cloud provides a lot of redundancy in the sense that if one component fails, the other component will take over that function, right? Fault tolerance is the ability of a system to sustain itself in the cases of failure, right? Example: so you have a component, you have a web server, let's say that server is going to go down, then your website will not be accessible to users. You need to have an alternative, right? That is fault tolerance. So scalability: ability to grow and shrink, right? So I talked about demand during festivals, right? During festivals, a lot of them are going to access your website and they're going to purchase material from your stores, right? Then you need more compute capacity. You need more web servers, right? So you can provision more web servers, right? So that is the ability to grow in size. And what is that? What is the shrink? Is if you don't want, you can release the extra resources, right? And so you don't need to pay for them. So depending on your need, you can use as much compute power as required. Elasticity, right? Again, it's the ability to grow when required and to reduce in size, like a rubber band, right? You can pull and it can come back to its previous size. It can stretch. So that is elasticity. So these are the things that we discussed in the basic introduction to cloud computing. What are the 6 important benefits, right? You already know because I mentioned some of them. So for example, I talked about agility, right? The ability to do things fast. Trade CapEx to OpEx. CapEx is capital expenditure. What is the capital expenditure? The servers, right? The networking equipment, right? The storage servers, the wiring, the space, right? For keeping all your servers, the storage and the administrators, all that comes under capital expenditure. And CapEx to OpEx, right? It's called as variable expense. So here you're only going to pay a monthly charge to AWS depending on your usage, right? In the case of cloud computing. So here he's explaining the details: capital expense and variable expense. Benefits from massive economies of scale. What is that? So many of us have accounts with AWS and we are using the services of AWS. As more users continue to use AWS services, it is economy of scale, massive, right? They are going to buy equipment in bulk, so they're going to get discounts and they're going to service a lot of consumers, right? And so when you purchase in huge quantity, you get a discount, right? Likewise, as more and more customers subscribe to AWS services, right? So we will get things cheaper and cheaper. That's what it means by benefit from massive economies of scale. Capacity planning, eliminate guessing on your capacity needs, right? So this is the overutilization and underutilization that we discussed. So we don't have to guess our capacity needs. So all these things we don't have to worry about. But in a traditional setup, you have a lot of such headaches which you need to be worrying about. Increased speed and agility. So I would like to give you an example here. In olden days, in the earlier days before cloud computing, whenever you want a specific server, right, it's a big process which could take anywhere between 3 to 6 months of time, right? So you have to do a purchase requisition, and that has to be approved by your manager, and then it goes to the purchase department, and then they send invitations, they get quotations from vendors, and then they study the specifications and then identify the vendor based on various factors like the performance of the computer, the cost, and various aspects. They study the quotations and finally decide on a vendor, and then the payment is made to the vendor, and then the equipment is bought. So this process, right, because of bureaucratic things that are going to be there, which takes time. There are so many intermediaries. It could take anywhere between 3 to 6 months, even for buying a computer, PC, right? So you can imagine if you have to wait for such an amount of time, what a waste it is. Today, I want to experiment something. All I have to do is go to AWS, create an account. Once I get the account, I can provision a server from a very simple, basic specification server to a very high-end server with large compute capacity and memory and storage in a matter of minutes, right? And then I can do my experiments, I can run my computational algorithms, scientific computing, whatever I'm doing, and then I can release that resource when I don't need it, right? Look at the amount of time we are saving here. Right, so the earlier environment was not conducive to innovation, experimentation, right? Because anything you want to do is going to take a lot of time. That's going to kill your innovative capacity, right? So, but whereas the cloud has given you the flexibility that at a very lower cost, right, depending on only the amount of time you use, so you can provision the resources that you need, and you can do your computations, you can run your experiments, right? And just you have to pay only for the time you use those resources. So that's why we say increased speed and agility. Stop spending money on running and maintaining data centers, right? It's a huge expense, starting from renting a place to keep your servers, right? Renting, buying equipment, then, right, you need to have manpower to maintain those servers. So it's a very costly thing, and we want to avoid that. And cloud gives you a way in which you can avoid all these costs. Stop spending money on data centers. So we want to give that to the cloud provider like Amazon. Let them worry about it. We will worry about our applications, right? So we'll not worry about racking and stacking and servers and computing. So we will use their services. Let Amazon worry about all these things. Go global in minutes, right? Ease of deployment. So if you want to deploy an application on a global scale, cloud gives you just the right environment for doing so. So these are the things that we discussed. So these are the 6 important advantages of cloud computing. And so here's a picture which I'll explain in the next slide. This talks about the AWS global infrastructure, right? So trade capital expenditure for variable expense or operational expense. Benefit from massive economies of scale. Eliminate guessing on your capacity needs. Increase speed and agility. Stop spending money to run and maintain data centers. Go global in minutes. So these are the various advantages of cloud computing. Now we come to the heart of today's topic, right? We are going to discuss AWS. We are here to talk about AWS. So AWS is a web service. Actually, AWS is also a web service. What is a web service? A web service is software that is going to help a client, right, exchange message with it. Right here, you're seeing a web service and a client, and they are exchanging messages. So your client, which is your computer, is sending a message to the web service. The web service understands that message and it responds to that message, right? Just like a client server model, right? But the web service is a software, right? The web service is a software. So these are all the various AWS services, and they are grouped under these headings. For example, you have compute services. Amazon EC2, which we are going to discuss, is a compute service. Then you have various storage and content delivery services. You have database service like RDS. You have networking services like VPC, right? So you have so many other services, but today's discussion, we will mainly touch upon the compute service, and if time permits, we will see the storage service, which is S3. So here you are able to see all the services grouped under various categories, right? You have the compute, networking, storage, and database. So all these are the compute services. They all have their own specification or scenario, right? When I want to use an EC2, when I want to use a Lambda, for example, right? So depending on your requirement, you will use one of these compute services. And these Amazon VPC we are going to see today tells you how to create your own virtual private cloud, right? So basically, you're going to create a network within the Amazon cloud, which is a private network, your network, right? So that's what it's equivalent to a LAN. You all might have heard of the term LAN, local area network. It's equivalent to a local area network within Amazon, right? Which you're going to create. So S3, EBS, EFS, they're all storage services. And RDS, DynamoDB, these are database services, right? Redshift is also a database service. It is used for data warehouse, creating a data warehouse. And it is a columnar database. RDS is a relational database service. And DynamoDB is a NoSQL database service, right? You all might have heard the term SQL databases and NoSQL databases. So RDS is a SQL database and DynamoDB is a NoSQL database. These are various other services like IoT, analytics, machine learning, right? Deep learning, artificial intelligence. You name it, they have a service. They have around 240 services as of date. And the number of services is growing by each month, I would say, right? So when I started cloud computing, it was around 150 services. And today I find that they have nearly 240 services, right? So every now and then they keep introducing a service. So they have a use case for that. Somebody who wants to use that service, and then based on that, they do experiments and they come up with new services very frequently. So these are the other services, and those of you who are interested can get a lot of details by going to the AWS website. Again, these are developer tools, management tools, security and identity, and app services, right? So CloudWatch, CloudFormation, CloudTrail, these are all very important services. As part of AWS Cloud Practitioner course, you must know about those services. So we do study about them in detail. Right, these are the ones that are going to be covered in detail for Cloud Practitioner. So the other ones, you are able to see that they are all dimmed. Only these are dark, right? So these services are not, I mean, they are there, but these are the core services. Means the most important services, right? These can be called the backbone of the networking. And these are the backbone of the computing, right? So these are the core services. And about all these core services, you will study in detail in the AWS Cloud Practitioner course. Again, these are security and identity and management tools. So these are the basic services. AWS services can be accessed through 3 different mechanisms. So you can use the console, AWS Management Console, and you can use the AWS command line, and you can also use AWS SDKs, right? So to explain this, when you use AWS console, you will be clicking buttons, right? You will just choose from drop downs, right? And you will enter information in a text box, and you will be clicking buttons. It's very easy to access the services through the AWS Management Console. But for those of you who are hungry for programming, you can use these. So this is using the command line interface. That means you'll be typing commands to access the services, right? So this, you will be running a software development kit, right, to access the services. So those of you who are programming, who have knowledge of programming and who wants to access the services through code, you can use these. Those of you who do not know much about programming, you just want to click buttons and access the services, you can use the AWS Management Console, right? So I'm going to show you how an AWS Management Console looks like. This is how it looks like. You're able to see all the services here, right? So all these are services under these headlines. So these are the compute services. These are the storage services, right? And then you will find for everything, these are the networking services. Right? Security, identity and compliance, management services, database services, right? Everything is there. So here, how I'll be using the service. Let's say I want to provision a virtual server in the cloud. Basically, I want to create my own virtual machine in the cloud, right? So this is the service I'll be using. I want to store some files. This is the service I'll be using. So let me just give you a small demo of the storage service, right? It's very simple to use. So let's try to store a file in that service. So S3 is SSS, and it stands for Simple Storage Service. As the name tells you, it's a storage service, right? It's going to give you the way to store a service. So you create what is called as a bucket. You can create the buckets, and the bucket names have to be unique, and he's giving you all the details. The bucket name must be unique across all existing bucket names in Amazon S3, right? So you have to create a unique bucket name. So I'm going to call it as my bucket, right? But then I want it to be unique. So I'll put some numbers, right? And let's see whether it is going to take this. I'm creating this bucket in the Singapore region. Let's say we want to create it in Mumbai region. So you can go and select Mumbai region, right? I'll come to regions in a short while, but this is how it is. So I just create, right? Simply you click on create. Bucket is equivalent to a folder, right? or a directory in Unix. So I've created the bucket. You're able to see that bucket here. So let me click on that bucket, right? And now it's telling you, what do you want to do? Do you want to upload a file into that bucket, right? So what I am doing is, this bucket is in the Mumbai region. It's been created in the Mumbai region, and I'm going to store a file in the cloud service. And the cloud service is S3, right? And through S3, I'm going to store a file. So I just click on upload, and you can choose any file that you want to upload from your local machine. Let's say I want to upload this file. So I click on it, right? And then I click on that. So you can upload multiple files as well. So let's say I want to upload this, right? Let's say I want to upload these two files, right? And then upload it, and you click on upload. So it is now uploading, and those files are uploaded, right? So my bucket contains these two files, right? From my local machine, I have uploaded those files into the cloud, right? So it's a storage service, but it has got a lot of powerful capability. It can be used to create static databases, right? Static websites. What do we mean by static websites? If I'm only going to render some material, right? So that is that website is going to allow you to utilize static content like files, images, videos, right? The moment you introduce a form which you have to fill, right, then that is not static, because the form details have to be analyzed. You have to capture what the user has entered in the form, so that is dynamic, right? When you don't have any forms or anything, you're just going to only render some images and text files. That is a static website. A lot of websites that we encounter are static. So for all such things, you can use S3 as a storage service. For storing all your HTML files and rendering them, you can use the S3 service, right? Okay, this is just to give you a demo. You were able to see how easy it is to use an AWS service, right? So if we go back to the slide here, we used it we used a service using the Management Console. Management Console, you just have to click buttons, that's all, right? You don't have to write any code. You don't need to know programming, in fact, right? You don't need to know any programming language. Anybody who just knows to read English and understand English can use the Management Console to use most of the AWS services, right? So those who are programming experts and who will only get satisfaction when they do it using code, for you, you have these things, the command line interface and the software development kits. Okay, now we go to the second part of it, and then we will have to do the demos as well. So we will go to the infrastructure part of it, and I'll explain what is infrastructure. So we will go to the second PPT. So in AWS infrastructure, things: regions, availability zones, and edge locations, right? So what is the AWS global infrastructure, right? So we will come to know when we go through those three things. So I will explain what those three concepts are, and even while showing the demo, I'll explain how we are using the regions, right, and availability zones. So this is talking about the AWS infrastructure overview. So we are going to see study about availability zones, regions, and edge locations. So we'll go to the important slides and I'll explain the concepts. Okay, so you are able to see here in the bottom the regions, availability zones, and edge locations. You are able to see those shown as infrastructure. AWS regions are located all over the world. For example, in India, we have Mumbai region. In Japan, they have Tokyo region. And in North America, they have 4 regions. They have one in Virginia, they have one in Canada, they have one in California, and they have a lot of regions in North America. In Europe also, they have 3 regions. One is there in the UK, Ireland, and one is there in Germany, Frankfurt. So you have a lot of regions, and the regions have what are called as availability zones. And the availability zones are clusters of data centers, right? So now your service is available on the cloud, right? But somebody should be hosting those servers. You're just using the service. So Amazon is responsible for the data centers. So they have all those data centers, and the regions have what is called as availability zones, and the availability zones are clusters of data centers. So we are going to see that now, right? So a data center is a location where actual physical data resides. A data center typically has 50,000 to 80,000 physical servers, right? Here they have just shown you a picture of a data center. So you are able to see a region, and inside that region you have availability zones, and those availability zones will be separated. For example, if it is going to be Chennai region, then one of the availability zones could be in North Chennai, the other one could be in South Chennai, right? If it's in Bangalore, one could be in, say, Devanahalli, and the other one could be on Mysore Road. So they will be separated by large distances, right? Why they do that? To ensure that if one availability zone, something is affected, right? That should not affect the other one. Let's say floods. If the flood is going to affect the south region, the north will be protected, right? And let's say the earthquake affected the south region, the north can be protected. So to ensure that if there is any mishap that is occurring in one availability zone, the other availability zone will not be affected, right? So here you're able to see all the regions, right? And the round circles are the regions, and the number inside that is the number of availability zones within a region. Mumbai has got 2 availability zones. Sydney has got 3 availability zones. Sao Paulo in Brazil has got 3 availability zones, right? So these are all the regions, and this is where the data centers are located. That means when you create a virtual machine on Amazon, your machine, your host is going to be in any of the regions which you choose, right? You have the flexibility to choose in which region you want to create your virtual machine. So your virtual machine will be residing in any of these regions, and within these regions in one of the availability zones. right? So the reason why they have multiple availability zones is fault tolerance, right? Something happens in one, fire damages one of them, the other one will be, so the availability zones will be separated by distances and they are connected by high speed links. So these are the new availability zones that are coming up, one in Sweden, one in Bahrain in the Middle East, and one is coming in the US East region. So Africa is the only continent that does not have one so far. I think very soon there will be one in Africa as well. Right, that's whatever I told you. So the availability zones are clusters of data centers, right? A region can have multiple availability zones and each availability zones has clusters of data centers, one or more data centers. And each data center could have anywhere between 50,000 to 80,000 servers, right? Why? Because the entire world is looking to AWS for their services, right? Now, so they need to buy the equipment, they need to maintain the servers, so they need to do all that, but we are all freed from all that issues. Amazon takes care of that. So they will build huge data centers everywhere, right? And inside these availability zones, they will create a lot of regions and availability zones, and all the machines, servers will be hosted from those regions. I mean, all these things are given. Edge location is another place in AWS. It's a global infrastructure where it has only caching servers, right? It's not going to have resources for your compute, database, and all those needs, but it has what are called as caching servers, right? Let me give you an example of this. Let's say you are rendering, you are watching a movie on Netflix and that is rendered live from a web server in US, right? Then it travels through the public internet. And so that rendering will be a little slow. There will be latency, right? Latency is a delay. So you might experience a delay and that will sort of, right, put the experience, you won't be, interested, because if a movie doesn't render fast, right, the user experience is going to be bad, right? I'm going to say, I just watched for 10 minutes and it was so slow, and right? So these edge locations will help to deliver the content faster, right? How that happens? What happens is, if Netflix is a customer of AWS, what they can do is they can send the content. Once a user requests for a movie, that content can be transported to an edge location near to that user. As you can see, the blue dots, the edge locations are also there all over the world. They are mostly in urban data centers, like near cities. So a user living in, say, Texas, right, could use an edge location in Houston, right? And from there to the, let's say this user is in Mysore, right? From there to Mysore, it could use the Amazon backbone network, right? We have edge locations in Chennai and Mumbai, and I think it's also there coming up in Delhi and Bangalore, right? So let's say the edge location is in Bangalore, then from the edge location in Houston to the Bangalore edge location, it will be transmitted through Amazon backbone network, which is going to be very fast, right? So it will be using the Amazon network, so it will be very fast. Only from the Bangalore edge location to Mysore, to your home in Mysore, it will travel through the public network, through the internet, right? So it will be very fast. Your video will be rendered very fast. So edge locations contain caching servers, and the caching servers, they cache content from origin servers, right? Origin servers are the place where the actual content resides, like your video, your image files, right? Your audio. So that is there present in the source or origin. From there, it will be cached by the nearest edge location, and then it will be transmitted to the nearest edge location next to the destination, right? So that is called as content service. So now we are going to see a demo of EC2. So a lot of these concepts will be explained when I do the demo. So we are going to do both a Linux server as well as a Windows server, so that you get an idea of how you do it. The moment I log in, this is going to be the home page of the AWS Management Console, right? So all the services are listed, and I want to use, I'm going to create a server, right? Virtual machine. So I'm going to click on EC2. EC2 stands for ECC, Elastic Compute Cloud. Okay, now there are certain things shown here. I have an account with AWS, so my name is listed here. This is my username, and you're able to see that it's created in Singapore. Let's select a different region. Say, let's say North Virginia. Let's create in US East, North Virginia. What this means is, I'm saying please, it should be hosted from a data center in North Virginia region in the USA, right? Why I chose it? Just randomly. I mean, but if you want a specific place, you can always choose, right? That's where your server is going to reside, right? The host machine for your server resides in North Virginia. So after that, go and click on Launch Instance. I'm going to create an Amazon EC2 instance, right? It's a virtual server, virtual machine. So click on Launch Instance. Now it is saying, please select the AMI. AMI stands for Amazon Machine Image. Whenever you want a machine, you want to give specifications for hardware and software, right? We want to tell which operating system we want to install on that machine. So the AMI tells you which operating system I want to install, right? I want to install a Linux server. So let me choose the this one, right? Amazon Linux AMI. So this will install a Linux operating system on my server. Let me select that. The next step is choosing the hardware components of your server, right? What are the things whenever you want to buy a laptop, what are the things you'll be concerned? Memory, RAM, how much RAM it has, right? What is the CPU power, right? We want to know that. The frequency of the CPU. What type of CPU? Is it an Intel CPU or AMD CPU, right? Which is who is the manufacturer? So those are all some of the hardware specifications. And I'm going to use an instance which is general purpose, and it's called as T2.micro, right? And it has got one virtual CPU, and it has got 1 GB of memory, right? A very basic configuration, because I'm just going to use it to demo virtual machine for you. So the first page, the previous page talked about the software configuration for your virtual machine. This page is talking about the hardware configuration, right? So let me choose T2.micro, right? For example, I want T2.micro, and I can do that. So what is this T2.micro, right? If you go down, you'll be seeing T3.nano, M5.xlarge, M5D.large, right? These are all families of instances, right? So general purpose means it has got a balanced mixture of compute power, storage, database, and networking, right? A balanced mix. That means all of them sort of balanced, right? But you can have special purpose instances. For example, you want to have where compute optimized. So you're doing some scientific computations, genomics, right? DNA analysis, or any pattern matching, string matching, anything that is going to be, you want to do a lot of computations. You want a lot of compute power. Then you can go for compute optimized instances. These all have a lot number of virtual CPUs, as you can see here, right? And they are identified by the prefix C. All the compute instances have a prefix C. You are able to see that, right? And what do you see after that? You see something like T1, T2, T3 and all. That is generation, right? You see T2 here, and then you also seen T3 down, right? T3. T2, T3 are all generations, right? That means T3 is the latest generation. T2 is an older generation. So that number denotes the generation. Then you see this nano, micro, small, medium, X large. It's like your t-shirt sizes, right? That means within the general purpose, I can have a very low configuration machine. I can have a good configuration machine and a high-end machine as well, right? So this nano, micro, small and all is going to give you the capacity that you want, right? Within general purpose, I can choose any of these capacities, right? So it tells you, you can clearly see that the difference between a T2 micro and a T2 small is a T2 micro gives you only 1 gigabit of memory, whereas T2 small gives you 2 GB of memory, right? You're able to see the difference here itself, right? So you also have memory optimized instances, right? You have graphical processing unit instances, right? You have FPGA instances, compute optimized instances, right? Storage optimized instances, memory optimized instances, right? All of them have a prefix which you can use to identify what type of instance it is. Right now you're able to see that you have a huge list of instances that you can select for your virtual machine, right? Which is going to give you enormous power, right? Starting from a very low-end configuration machine to a very high-end machine you can get, right? The cost will also differ depending on the type of the instance, right? So the cost is going to differ. If you choose a high-end one with a lot of memory or CPU power or storage, you have to pay more. So depending on the configuration of the instance, you're going to pay more. Okay, now let's go to the next page. So we have selected the software, the operating system. We have selected the hardware. Now let's go to the next page. Right, so the one that we have selected is T2.micro. Okay, so this page is going to talk about the number of instances you want to be created, right? In which network you want it to be created, right? There is a VPC created, and then you want to know which subnet you want it to be created. So I select a subnet, right? So what these two is doing is, I told you that VPC is like a LAN, right? You want to create a VPC, it is like a LAN. So let me show you a configuration for how to create a VPC, right? Then we can come back to this. So go to VPC. I want to create my private network within the cloud. So then I will use the VPC console, right? And let's go through a simple creation of a VPC, and then we will do the EC2 instance. I'm going to launch the VPC wizard, which is going to guide me in creation of the VPC. This is what I want to do, right? With a single public subnet. So I'll explain to you what a public subnet means. So a VPC is a network. So how do you define a network? A network is defined by the IP addresses, right? By the IP addresses that are used to categorize that network. So whenever you say network, you will talk about the IP addresses, and this is one way of defining the IP addresses using what is called as a CIDR block, right? It's called classless interdomain routing block. This tells me that my network is a large network which has got as many as 65,000 hosts, right? That's what you just understand that we are creating a network. I'm going to say my VPC. I'm going to call it by a name. I create a subnetwork. A subnetwork is basically partitioning a network into two or more parts, right? Depending on your requirement. So I'm just creating a subnetwork from within this network. Again, the subnetwork is also identified by a CIDR block, and this tells me that there is going to be 256 hosts in this subnet, right? How do you know that? What you have to do is look at the number in the last. That tells you the number of bits that are 1 in your subnet. Subtract this from 32, and that is going to be the number of hosts, right? So like this. So I'm going to show you that. So the number there is 24, right? So you have to subtract it from 32. So that's going to be 8. So the number of hosts in that subnet or subnetwork is going to be 2 power 8, right? So 2 power 8, and that is 256, right? So if I make a change here, if I say 26 or let's say 26, right, then simply you just have to subtract 26 from 32, right? That is going to be 6. And then 2 power, you have to do 2 power of 6, and that is going to be 64. Right? So in this subnet, you have 256 IP addresses which you can assign to 256 hosts. Right? So that's what it means. So just I'm giving you a basic understanding for those who are not aware of the CIDR block notation. When you define a network, you are going to say what are the IP addresses that are part of that network. That's what you are going to do. Right? Here I'm creating a network, and then I'm creating a subnet, and I'm assigning some addresses to the subnet. Now, what are the addresses that are going to be part of this subnet? I told you it is going to be 256, right? So I told you it's going to be 256. So you can now decipher what will be the IP addresses. First IP address will be all 8 bits, right? The last one will be all 8 bits set to 1. Those of you who know binary, you will be able to understand. Those of you who do not know about binary, just take that there will be 256 IP addresses in this defined with this subnet. That means 256 computers in that network can get a private IP address, right? So I also need to tell you the difference between private and public. So if you have a machine acting as a web server, and then it is accessible to the entire world, right? Anybody can access a web page. So then it has to have what is called as a public IP address, right? If it's only going to be within your network, you just need to communicate within your network, intranet, then those machines need not have a public IP, right? Then you can just give them a private IP. Take the example of your home, where you can have a home router, right? And you can have multiple devices connected to the home router, and like your laptop, palm top, right? Your mobile, and it can be connected through a wireless router. And so there are a lot of devices that need to communicate to the internet, but all of them don't need a public IP address, right? Because your router is going to be the interface to all these devices. So it is fine if you give the router a public IP address, and all these devices in your home can just have a private IP address, right? So basically I created a subnetwork. Then I'm going to choose a availability zone where I want to create, right, the subnet, right? I'm choosing availability zone, right? You're able to see the region here. I told you that my virtual machine is going to be created in the North Virginia region of USA, right? And in that region, there are 6 availability zones, right? These availability zones contain clusters of data centers, and all these availability zones are separated by physical distance, right? Within the Virginia region, they are all within the Virginia region, but they are all separated physically by several kilometers, right? So you have so much of availability centers. That means you have so much of computing power storage, network, and databases in these availability zones. So what I'm saying is my subnet is going to be in US East 1A. US East is Virginia, North Virginia, and 1A is a specific availability center under North Virginia, right? And public subnet, I want to create a public subnet, and I say create VPC. It's now creating the VPC. So inside the VPC, within the subnet, now you can create your EC2 instance, right? Let's do that now. We will do the launch instance. Linux. This is the operating system that we are selecting. And this is the hardware configuration for the machine that we are selecting, like CPU, RAM, right? So then we go to the instance configuration. Now there is a VPC, so let me choose this VPC and a subnet, right? I want a public IP address. So because I'm going to run a web server, right? So I want a public IP address. So I say, please give this machine that I'm creating a public IP address so that I can connect to it from anywhere, right? So this I want. Then let me say enable termination protection. So somebody is trying to terminate, please don't allow. That's what it means, right? And we are fine, right? Let's go ahead and create the instance. So I'm going to put a script, copy that script, and I'm going to paste it there. I will explain to you what I'm doing with that script. But right now, I'll just paste the contents of that script. Now I'm going to add storage. Yeah, this first one, we decided on the memory and the RAM, right? Now we are deciding on the disk space. How much disk space do I want, right? That's what we are doing here. So I'm going to use a root volume with 8 gigabit of memory. If you want, you can change this, right? And I'm just clicking on add tags. A tag is identifying. We are all identified by a name, right? Suppose I have 100 virtual machines created, right? I need to identify. One is acting as a database server. One is acting as a web server. The other one is acting as a file server, right? So I just need to give a name. So let me call this server as, right? I'm calling it as EPSet web server, right? EPSet web server. We call it as WS. Right, this is just a name that I'm giving to this machine, right? Tagging is just giving a name. Configure security groups. So I will explain this to you when I give you a demo. So right now, just follow what I'm doing, but I'll give you a demo. Security groups is basically telling you what traffic can get inside and out of your instance, right? Basically what traffic can be accessed. So I have an instance, right? I have to protect that instance from outsiders. Security is a very important perspective, right? So you saw about firewalls, and I told you that the equivalent of firewalls in AWS is called as security groups. This is what I'm doing, right? I'm selecting what type of messages, right? What protocol, what port numbers should be enabled, right? For communication between my server and the other devices, right? So here we select the type of protocol, right? And the port that should be opened for communication. And then this means that anybody from the internet can connect, right? This is just for demo, so I'm just allowing it, but strictly you should restrict the source by putting an IP address or a range of IP address. If you put an IP address, what it means is your machine can only get messages from this IP, this machine. Others cannot communicate with you. If you give a range of IP address here, what it means is your server that you are creating can only be accessed from these machines, right? That's what it means. So we define the protocol, the type, right, which is basically telling what type of message, and then the protocol that is used, then the port that should be opened for communication, right? Ports are identified with applications. When you use the email, it uses a specific port. When you are browsing the web, those messages use a specific port called 80, right? So each application has got a port, and that port we have to enable on our server, then only it can communicate, right? So depending on the application type, you have to enable the specific port, right? So every application has got a default port, but you can also change the default by configuring it. Okay, so now this is clear. So we have defined the security group. Now let's go to the next step. Oh, you have to give a name for the security group, right? I'm going to give WebSG. Right, now check all your instance configuration, see everything is fine, right? Then launch. Now we have launched our virtual machine. Now choose an existing key pair. Now let me say I want to create a new key pair, right? So before we do this, let me explain to you what a key pair is. A key pair is like two keys, right, which match with each other. One is called as a public key and the other is called as a private key, right? So when you create an instance, right, so let's an analogy will be a lock and a key. Only the specific key can open a lock, right? So what we are going to do is the lock is going to be with the server and the key is going to be with me. So only if I give the correct key, the lock will open. So the server will allow me to communicate with it only if I give the proper key. So at the time of creation, you create this key pair. One of the key is going to be with me, the other key is going to be with the server that I'm creating. So when I try to communicate with the server, if I don't give this key, it won't allow me to log inside, right? So the key pair is used to authenticate who you say you are, right? So when instance is created, you're also going to create a key pair and you're going to store that key pair on your machine. And whenever you want to communicate with that machine, virtual machine, you have to give that key pair for authentication, right? So now I'm going to create a new key pair. Let me call it as my key pair, right? Or I'll call it as demo key pair. Let me download the key pair. So the key pair, the private key has been downloaded into my machine. You're able to see that here, right? And now I'm ready to launch that instance. Okay, while it launches the instance, the instance is launched now, and you will be able to see in the EC2 dashboard the details about that instance. This is the public IP of my server, and all these are metadata about the server, right? My server has got this ID. It's uniquely identified by this number, right? And it has got an IP address, and I can communicate it with this IP address. And it has got the security groups, which availability zone it's created in Virginia East 1A. There are 6 availability zones, and it's created under 1A, right? Now let me go ahead and type this IP address onto my browser. Okay. So This is public IP, right? And the configuration, there may be some issues. Let us try to connect to it through PuTTY. So our web server is up and running. So it took a few minutes, right? So this is my web server's IP address, right? Whenever you type the URL name or the IP address, it will show you the web page, right? For example, when I type google.com, that is the URL. And here, this is the URL, right? AmazonAWS.com, because it's created in Amazon's infrastructure. So it will have this AmazonAWS.com. Right? And then this is the IP address of the web server. Every web server has to have a public IP. So, right, all I did was type it, and now the web server is up and running, and it is displaying this message, right? So we welcome all the participants to the cloud computing webinar hosted by EPCET. We thank the principal, HOD, Nandini madam, Shafali madam, and all the organizers from EPCET for providing the participants an opportunity to deep dive into the world of cloud computing with Amazon Web Services, right? So I would like to also thank our director, Mr. Parameshwaran, and also all the help that I received from AWS, Mr. Amit and Mr. Vishram Tate, right? Because I have developed a lot of knowledge on cloud computing because of them. So I would like to thank all these people. And I would also thank all of you, the participants who are participating in this webinar, right? So this website is hosted by the web server that we created, right? I copied a content of a file, but I didn't explain what it is. I'll explain now what I did. What I'm saying is, the machine that I'm creating, please configure it as a web server. So I'm installing what is called as a HTTPD service, Apache web server. HTTPD is a web server installation. So I'm installing it here, right? Then I am turning it on, the service. Then I'm starting that service, right? These are all Linux commands for starting that service, right? And then I am creating a simple web page called index.html, and I'm putting it into a directory on the Linux server at this place, /var/www/html, right? So when you create a website on Unix, it has got a specific partition where you have to store the web pages, right? That is under var www.html, right? So this code, this script that I copied at the time of creation, it got executed after the server got created, and then it installed the service, right? And then it started the service, right? And then this page is printed, because when you go to a default web server, it's going to take the default home page, or which is called usually with index.html, and it is going to display the contents of that page. That's what you're seeing here, right? So we just created a virtual machine, and that virtual machine is not physically present in our place. It is present in the cloud, right? Where exactly it is? Where exactly is the hardware associated with this virtual machine? It is in the North Virginia region in the USA, in one of the availability centers, right? It has got 6 availability centers, and this machine is there in one of the regions. Okay. Now let me go to get a terminal for this one, right? Let me quickly get a terminal for this one. So I can go to PutyGen and I can load the PEM files. I created a file called, so I can type here star.pem, right? I have a demo kp.pem, so I open it, then I save the private key with a passphrase to it, right? I want to store it in documents, so let me call it as demo, right? And then I saved it. So I have to save it in documents. Yeah, now that machine is, so let's try to log into that server, right? So we are going to now log into that server, and I'm going to use Putty for that. You might have heard about Putty. Putty is a tool which is going to help me log into a remote server. So what is the IP address, right? I need the IP address. So let me copy the IP address of the web server, and then I can copy that. Now you also have to authenticate, right? That's why we downloaded the keypad, right? So you have to specify that key file that you created, that you downloaded. Without the key file, it will not authenticate me, right? So with that, I can try to log in, and network error, connection refused, right? So what is that? Let me try it again. .34.329, and then go to SSH auth and demo.ppk. Okay, so let me try demo kp.pem. So let me try converting it again. Yeah, I need PutyGen only. Yeah, PutyGen. I go to the application and I load. Here you have to say all files, then star pem. So demo kp.pem. So I open it, then it created, then save private key. So in downloads, let me call demo kp. Okay, so some issues there. We can quickly troubleshoot it by identifying the security groups, because there could be an issue with the security group. So let us go to the security groups. Yeah, here. View inbound rules. So let us go to the web security group, and we can click on the inbound and outbound rules and check if we have allowed SSH, right? So this is the security group, and let's look at the inbound rules. See, we have not allowed, SSH is allowed, right? Actually, SSH is allowed. Okay, we will try to figure out, what is the issue. Before that, I also want to show a Windows server. So let me quickly go ahead and do the Windows server demo. Also, we have a short time. So it's the steps are the same. Only finally, there will be a few changes. So I will explain those steps. Because of paucity of time, we won't be able to go into detailed explanation, but most of the steps are same for the Windows server also. So now you have to select a Windows free tier eligible one instead of Linux. So I go and select one of the Windows servers available. So let me choose this. So I've chosen an operating system. So I leave all the other configuration as the default. T2 micro is fine. Say hardware configuration. Now I go and select. Again, I want a public IP, so I enable it. Same VPC, and let's say we want to use a different availability zone. I want to host it in a different availability zone, right? And then all other things are going to be the same, right? So you want to prevent against accidental termination, you can select this. And yeah, I think all other things are going to be the same. Storage is the disk space that you want, and we are fine with it. Tag, no, let me call it as Win server. Configure security group. So I also want it as a web server, right? So you have to allow HTTP traffic, right? That is fine. So I will call that as WinSG, Windows security group. After that, you're going to review, and all these are fine, and launch. Then key pair. Let's create a new key pair. WinKP. Download the key pair. So WinKP is downloaded. So everything is same, right? Up to now, everything is same except the operating system, which we chose as Windows. All other things are same. Now the instance is now launching. So it's going to take a couple of minutes. So let's go and examine the instance. So it is actually creating that machine, right? So in the meanwhile, while this is going on, I'll try to cover some of the topics that I had actually wanted to cover. So Cloud Practitioner strategy guide, right? You want to know what are the things that you need to prepare for this for the Cloud Practitioner. So I prepared a sort of a strategy guide, which you can follow. So You will be doing labs as part of this. The labs are the ones that is going to give you a lot of conceptual understanding about the AWS services. Then we have a study guide in which a lot of the AWS services are explained in detail. Then you can go through Knowledge India videos from YouTube. There are white papers that you must study to understand about some of the services. And then AWS provides the course PPTs. Whatever you are seeing is the course material provided by AWS, right? So the labs and the course material are provided by AWS. And this is from YouTube. Anybody can watch. And white papers are all available for anybody to download, right? They are all available on the AWS website. We can download, and I have a copy of study guide which I can share with any of you, whoever is interested. So these are the things that are explained here, and what are the important things for the course, right? So I've just explained important tips for those who want to prepare for AWS Cloud Certification course. Which are all the important services among these? That's what I'm showing here. Right? So you must understand those things. So Bartholomew has prepared a mind map. So that mind map is sort of help you associate the services with the functionalities that they do, right? So there are a lot of services. This is a sort of a memory mind map which helps you sort of remember things. Flashcards are used again for identifying the important roles of those services. There's a cheat sheet also available for AWS, which you can browse. Important points are listed in the cheat sheet, and all these things you can go through. So which are all the important topics for AWS that is listed here, right? So of course we cannot cover in a 2-hour session all these details. So this is just for those who want to prepare for AWS CP. Now let's go and check whether the Windows server is up and running, right? So yeah, so this is the Windows server. So I select it and say connect, and then it is going to say get password, because again I have to log into the server, right? I need the password. For that I have to choose the key file that I created, right? Key file, I go to downloads and say *PEM. I created the winkp.pem. So I give that service, then I say decrypt password. So it has given me the password, decrypted password. So let me copy it over to my clipboard. Right, let's close this, and you're going to use a remote desktop service. Whenever you want to connect to a Linux machine, you use the PuTTY tool, and whenever you want to connect to the Windows, you use what is called as a remote desktop connection, right? So which server you want to connect to? You want to connect to the Windows server with this public IP, so copy that and then paste it over here. This is the server I want to be communicating. Click on connect, and it's asking for username and password, and just now you got those details, right, which you have saved. So username is administrator and this is the password. So let me copy the password. So while this is going on, there is something called as a shared responsibility model in AWS. Shared responsibility model tells that these are the things that I'm going to take care, and these are the things that you should take care, right? AWS clearly defines the perimeters of the responsibility between the customer and itself. AWS tells that These are the things that I will be responsible for, and these are the things that you should be responsible for. Anything related to your application, your data, you are responsible. Anything related to the infrastructure, like the virtual machine, right? The patching of the operating systems, whatever is involved. So those are all the responsibilities of AWS. So now we have got our virtual server. So this is the virtual machine that we have created, right? We've got our virtual server, and we need to now connect. We want to install the web server on this, right? So we go here, and this is a Windows machine. So I've got the start here. So I click on that. I have what is called as a server manager. I click on server manager. So this is my Windows machine, right? Okay. And then we are going to say add roles and features. Basically, we want to install our web server. For Windows machines, the web server is called as IaaS, Internet Information Service, right? We use what is called as an IaaS server. So we are going to install that server on this machine. So go to installation type and select role-based or feature-based installation, and go to, this is your machine, Windows virtual machine that you have created, and select the specific service that you want. Okay, I don't want file storage service. What I want is web server. Click on this, click on add features, go next. Again, leave all these to the default. It is here selecting all the additional services that are required for running this service. So click on next, and then install. Click on install, right? So while this is going to take a few minutes, right? So we've just now created a Windows machine, virtual machine, and we are configuring the web server on a Windows machine, right? So this is how you configure a IaaS server on a Windows machine. So this is going to take a couple of minutes. In the meanwhile, let's go and examine our Linux instance, right? It is now Linux is also launching. So while the Linux is launching, let's go back to our Windows Server. Installation is completed. IIS web server installation is completed. So I close it. Now let's see whether it works, right? So let's go over there and close the server manager, and we'll try to go to a website and test that we are able to go to a website, right? So this is server manager. Let me close it. And now let's go to a website and see whether the server is working fine. So fine, don't ask me again. So 127.0.0.1 is a loopback address, means it's communicating with the same machine. It's called as a loopback address. Now we are able to see our internet is working. So we have configured a web server successfully. So I'm able to see that Microsoft IIS has been successfully installed. Let's go to a website, right? So say google.co.in. Okay, the content has been blocked, and see now it has gone to the Google search page, right? We want to go to EPSET. We want to go to their website, right? Again, it is giving because of the security restrictions. Website will be redirected. Click here if you're not redirected. Click on add and add. Close. Okay, now you got at least the EPSET web page, right? Yeah, East Point group of institutions. You're able to, right now your web server, your Windows server is also configured as a web server, right? You're able to access other websites. You're able to see that, right? Okay, so now the Linux machine also should be launched, right? And hopefully, so let's go to EC2. In just 5 minutes, I'll leave it for audience to ask questions. So in just 5 minutes, right? So we'll be completing the demo of Linux also, right? The instances are there. You'll be able to see the instances by clicking here, going to the instances page, and I created a Linux instance now, right? And that is also configured as a web server. So if you click here, you will get the details of that web server, and you can go and paste it. Yeah, so it is working fine. Only thing that we have to now try is communicating it through the shell, right? I mean, through getting a terminal window. So quickly we'll do it in 2 minutes, and then I will leave it open to the audience for discussion. So we will do a putty gen, and I have to convert that private key. This is the one that I created for the Linux instance. Then save private key. And here I'm going to call it as Linux KP. All right, so that is saved. Now go to putty and see if you can connect to it. What I did was the key pair, I downloaded the private key, right? You saw that. So the private key is in a PEM format. So when you try to, authenticate yourself, it is not the correct format. So I converted into PPK format. PPK stands for putty private key. So your instance will understand only if you send. Linux instance only will understand the PPK format. So I converted the key file in PEM format to PPK format. That is what I did there in that step. Now I'm opening my putty, and now you are actually trying to connect with your Linux instance. So you need to go and get the IP address of the Linux instance, right? So right now we are actually pointing to the Linux instance. You can go back and forth between the different instances. And when you go to this instance, the metadata of that instance is visible here. So, but I want to now go to the Linux instance. So I will go to that instance and I'll copy this IP address, right? Then go to putty, and EC2 user is a default username, EC2 -user. And I'm going to copy the password, and I need to ensure that the password is correctly copied. And then now you have to give the PPK file for authorizing you. So the PPK file that I used was called as Linux KP. So I give that, right? And then I click on open. Network error, connection refused. Okay. Again, it is not. So let me try to check my security groups. SSH. So inbound rules are fine. I'm using SSH and TCP and HTTP. So outbound rules is allowing all traffic. So that looks fine, right? So, and key pair authentication is also complete, right? We were able to save the private key file. One thing I want to check is what is the VPC and what is the NACL listing. So I want to check the VPC. So if you get an issue like this, what are the things that you should troubleshoot? Check that, right? Your protocol port configuration, everything is allowed in security groups. Then you also have to look at other security mechanisms like NACLs, right? That's what I'm going to show you now. So, so go to the Linux server, and you're able to see these things. So it is in the VPC details are given here. So let me copy the VPC, and this is the VPC in which it is deployed. And so I copied the VPC. Now you can go to that VPC and check what NACL is deployed. Oh, okay. I think I've already, late overshot the time by 10 minutes. So I will start answering the questions in the meanwhile. So please let me know what are the questions that the students have, and I'll be happy to answer them.
Hello,
Yeah.
sir.
Yes, go ahead. Please go ahead.
Now, the Shifali ma'am, Assistant Professor, EPCP, will be taking care of questionnaire sessions. Over to you, Shifali ma'am.
Yeah, thank you, ma'am. Hello, everyone. Shifali here from ISC department. It's my pleasure to be a part of this webinar. So let's start with the question answer session. And one announcement that a feedback link has been shared, or maybe they are sharing soon. So please fill the feedback form. So let's see the first question: how the IP address outside access into the network created as private.
Okay. Okay. So when I
One
created
second,
it,
sir. 1 second, sir. Bhaskaran sir, can you stop sharing the screen?
1 second. Okay. Yeah. I'll stop sharing the screen. 1 second. I'm just checking all the protocol rules. Okay. I have to go to that screen and StreamYard and yes. Yeah.
Yes, sir.
Yeah. Yes. To answer that question, when I created an instance, you all would have noticed I created enable. I selected enable, right, in one of the configurations. Basically, what I said is this instance is going to be a web server. So basically, because I want to configure an instance as a web server, I want a public IP address. There is enable and disable, and you would have seen me selecting enable. That means please give a public IP address to this instance. Every instance that you create within the VPC will get a private IP address. Every instance will get. In addition to that, if you click on that enable, your instance will also get a public IP address. When do you need to enable? Whenever your instance is going to act as a web server, or whenever your instance is going to act as other servers where requests could come on the internet, right? Then you have to have a private public IP for that instance. But whereas when your server is going to act as a database server in tier 2 or tier 3 or an application server in tier 2, right, it doesn't need to communicate directly with the internet, right? In that case, it can have only a private IP address, right? So a load balancer will have a public IP, and the load balancer will be the contact for the outside world, and then the load balancer will distribute the load to the application servers, right? In that case, those servers that you configure need not have a public IP. So you decide whether you want a public IP or not. Did I answer your question?
Yes, sir.
Okay.
Yeah. So one more question from Sunanda. What are the tools to log into the cloud environment?
What are the tools to log into the cloud environment? Okay, so what she means is, how do you know who is actually accessing the service and all those details, right? So there is a service called CloudTrail, and the CloudTrail is used to capture all the transactions that you do with the cloud, right? Behind the scenes, it uses what are called as API, application interfaces, right? So those APIs are used. So when you upload a file into a S3 bucket, like what I showed you in the demo, an API is used internally. You click a button, but when you click the button, internally code is executed, and that code uses the specific API to actually do that action, right? So all these activities, so whenever you use an API, right, it talks about which account user is using that API, right? What was the time at which that API was used and which service was accessed, right? Every service will have a specific API, number of APIs. With EC2, you have a huge number of APIs that you can use with EC2, right? For example, stop an instance, you use a specific API. You will be clicking a button internally that will be calling that code, right, which uses that API. So shut down a service, create a service. Everything happens in the form of executing application programming interfaces or APIs, right? At a higher level, we don't understand code. So for us, the management console is very nice. We just have to click buttons, right? But internally, everything calls the API. All that is hidden from our view, it is abstracted from us, so that we don't have to worry about the internal details of how a file is uploaded into an S3 bucket. All we need to see is, I want to upload, I click on that button, upload, and it gets uploaded. I want to download, I click on that button and it gets downloaded to my machine, right? As a user, we are not worried about the details, internal details. Okay, did I answer your question? Yes, please go ahead.
Yes.
Yeah.
So one more question from students' point of view. What type of projects students can do on AWS?
Okay, so there are a lot of projects that students can do with AWS. I didn't talk about a service called Lambda, which is widely used. Lambda is a serverless compute service, right? What do we mean by serverless compute? Lambda can be used. You don't have to provision an instance like what you did now, right? Lambda can be used to execute code in the case of events, right? Let me give you a typical scenario, right? You are downloading some student marks into a S3 bucket, right? I create all the student marks in an Excel file or whatever, text file or whatever. And then let's say I upload that into an S3 bucket. Uploading a file into an S3 bucket is an event. That event can trigger a lot of actions, right? So you can have a Lambda function get executed whenever you upload an S3 file, a file into an S3 bucket, right? I uploaded the score sheet of our students marks into a S3 bucket, and immediately that will trigger a Lambda function. That's an event. Upload of a file into S3 bucket is an event. It can trigger a Lambda function, and the Lambda function can read the marks from the Excel file. It has got functions to do that. You can use a lot of functions. Lambda functions can be written in Python, Node.js, Java, right? Just all the important languages. And you can examine the contents of the file, and you can take the data and you can populate it into a relational database, right? And you can store the contents into a relational database. So this is just one example I'm telling you. There's a lot of interesting use cases and scenarios. When you learn about all these services, you will learn about all the use cases associated with those services. Let's take another example, the SQS service. SQS is a queue service, right? There is a producer and there is a consumer. The producer is producing a lot of messages, and the consumer may not be in a position to consume the messages in that order in which the producers are producing, right? Then you need an intermediate entity to store all the messages that come from producer, and then the consumer can take those messages and process them whenever it wants. It doesn't have to work at the same rate as the producer, right? So if the producer is producing a large amount of messages which has to be processed and the consumer is not ready, what will happen in the normal scenario? Messages will be lost because the consumer is not ready to take new messages, right? Messages will be lost. But SQS is a service provided by AWS which allows you to store all those messages, right? It's a huge size. You can store any number of messages. And then those messages can be accessed by the consumer at its own pace. It doesn't have to catch up with the producer, right? Let's say example. So we are all buying on Amazon platform, right? Amazon, Flipkart, and all these things we go and we buy online purchases, right? So those are the events that occur when you do an online purchase, right? So many people can purchase within a minute, right? All those things, let's say another process is running to consume that. But then it's not able to take care of this load because per second there are about 500 purchases or 5,000 purchases maybe, right? It's not able to handle, right? So in this scenario, what you can have is, even though you can have a large number of consumer processes also, which can extract the information from the user and generate the bill and all those things, it will be better to store the things in a queue. And I heard that's what Amazon does, right? It captures all the details of the buyer and stores it into the queue, and then the other process will process it and will pass it on to the delivery department or whatever, and then the delivery department will take care of delivery of those items, right? So there are a lot of interesting projects and scenarios, and once you read it, it's so interesting and you will get immersed in AWS. Okay, any other questions?
Yes. In the interest of time, one last question we will take, and the question is, students should go for which kind of certification for their kickstart career?
Okay, so I would advise students, I want to tell you the scenario of what happened with the AWS Certified Solutions Architect. AWS Cloud Practitioner is a recent introduction. It was introduced just about 2 years back, 2 or 3 years back, right? Less than 3 years back. So earlier, the first step itself was Certified Solutions Architect. And students found it very difficult, and especially in countries like India, it was not much of a success. So then they revised the strategy and they said that this step is too steep to climb for most students. So let us put an intermediate step. So they created a new level or a new step for before you climb on to the next step, right? That intermediate step is what is called as the cloud practitioner. So the cloud practitioner is sort of a first jump for you to go to the next level, which is certified solutions architect, right? Certified solutions architect are a valued certification, and all of you must strive ultimately to reach or to undergo the certified solutions architect certification and clear it. But the CP is a first step for you, right? So so they brought an intermediate step so that you climb one step and then go for the next step, right? So that it'll be easier for you. And since CP came, the success rate has improved, right? So I told you in the beginning that we had about 67 cloud practitioners. So students are clearing. And if we put more effort, and if students put more effort, more number of people can clear CP, right? But the ultimate aim of every student should be the certified solutions architect. That's a very coveted certification, and that is a high level certification where you study about all these services that I mentioned in a great more detail, right? So I would suggest that all of you should ultimately aim for the certified solutions architect exam, and this CP could be a first step, right? So all of you clear CP, and if you're not able to clear CSA, it's fine. At least you have some certification in cloud. It will definitely be a value add for your resume, right? So cloud services, as you know, that they are within the top 5 certifications. You take any website, everybody has listed AWS certifications within the top 5. Sometimes it's the second or third, like that, right? So these are all very valued certifications, and in the current era of cloud computing, it is a must that everybody should know about AWS, because AWS is the leading cloud services provider with close to 50% capture of the market, around 45 or 47%, right, of the cloud services market. They were the first ones to pitch into the cloud computing thing, and so they are far ahead of their other competitors like Microsoft Azure and Google Cloud Platform, right? So it is important that all of you get into this because it's very interesting, and it is an ocean, I would say, right? I mean, you can keep getting yourself certified, and there are so many certifications. There's a system operation, SysOps certifications, there's a DevOps certification, there is a cloud practitioner, there's a CSA associate, there's a CSA professional, right? They are coming up with new certifications for big data, machine learning, and all those things. So it is an ocean, right? I mean, so there's no end to learning as far as AWS is concerned, right? Just like any other domain, right? It's an ocean.
Sir, one student asked, any branch student can do this certification from
any
Girish.
branch student can do the certification. So take that thing out of your mind, right? I am not a CSC student, right? I cannot do this. No. Very basic knowledge of networking you require, which you will get by watching an hour of video on the YouTube. Just to learn about what is a private IP address, what's a public IP address, what's a NAT gateway. All these things you can learn by just watching an hour of video on YouTube. So any graduate who has the interest and who can put the effort, right? Some effort is required. CP, the effort is less. CSA, the effort is more. So some effort is required on your part, right? So there are, for example, here, to give you a picture, the number of students certified is 67, right? But the total number is over 200. Total number of students who attended is over 200. So it doesn't mean that all of them get certified. So did all of them take the exam? No. Majority of them did not take, but we had very few failures. Total, I think about 3 or 4 have failed. So we only had about 71 or 72 students who took the exam, and only 3 or 4 failed. So we got a very good success rate. But then if you look at the number of students who registered for the course and attended the course, that is a big number, right? So that is only, we have had only 30% success. That means out of 100, every 100 students who register for the course, CP course, only 30 register, right? You can imagine what will happen if it is for the CSA, right? It's going to be it will be a very low number. So 30% is not a very high number, right? That means students register and they get interested, but then afterwards they don't put the effort. You have to put the effort, and that will give you the confidence to take the exam. But to tell you frankly, CP will require only a month of preparation for about 1 or 2 hours every day. That's all, right? It is not a very difficult exam. It's an awareness exam. You look at the CP questions, right? And I have shared the links with Nandini madam, Shefali madam, and if any of you are interested, I can share you the links. So I will give you my email address. Any of you are interested, you can write to me and I can share the links of the materials, right? So please find it here.
So one last question from Shukla sir. Yeah, he's from EPCD. The question is, what is the status of having the complete infrastructure for cloud services in India to be self-reliant?
Okay, so as I said, being a cloud service provider is not an easy task. You have to invest billions and billions of dollars to actually create the infrastructure. You saw that each availability zone has several data centers, and each data center is a cluster of 50,000 to 80,000 hosts, machines, right? So that kind of a massive infrastructure, only big companies will be able to, invest, right? It's very difficult, right, with that sort of thing. But what others can do is they can do software as a service, where they provide the software. It's hosted on a cloud provider, right? They develop that software and that is given that. So most of the cloud service providers, they provide softwares for usage, right? But for infrastructure, very few of them can actually get into that market because it is going to be very, very expensive, right? Not every player can get into the cloud infrastructure market. It is a lot of investment, effort, right? Planning, design, execution, right? So it is extremely difficult. So you see only the top players there, like Microsoft Azure, Google Cloud Platform, Amazon Web Services. Only they can invest that kind of money. Yes, any other questions?
Thank you so much, sir. I think we are done with the questions now. With interest of, we would like to stop here itself.
Okay, yeah. I'm very sorry. It's almost 20 minutes beyond time, right? I mean, I'm very sorry about that.
No problem, sir. I think audience enjoyed a lot, and
Okay.
I would like to start with the vote of thanks now.
Okay.
I would like to thank Professor Bhaskaran Venkataram, sir, on behalf of EPCT for accepting our invitation to be a resource person and to present a webinar on AWS Cloud Practitioner Essentials and to take out his precious time for us. Sir, it was a wonderful session where audience learned about the core services of AWS like EC2, S3, VPC with hands-on demo and a lot of practical examples with the use cases. I can endorse that what the students and faculties have learned today will definitely take them to a long journey of learning the cloud computing and will let them to deep dive technology. Thank you so much, sir.
Thank you so much. So I would just like to add a sentence. So please take up, you have to learn all the new technologies. So we cannot be like, I won't learn about these things. So all of us have to learn, right? Current generation especially, right? Companies expect you to learn things very quick, learn new skills very fast. So all these things, learning new skills, and especially when AWS is providing everything for free, right? Those of you from other colleges, apart from Amrita and East Point, right, you have to get your faculties involved with the AWS coordinators, and they will assist you in taking the program in your colleges, right? So we can give you the contact details. So you know my email address, right? You have the details of Nandini madam and Shefali madam. So we are all in touch with AWS people, and you have to ask your faculty members to contact them, and they will initiate you through the process, right? So I want to thank the East Point College principal HOD, Nandini madam, Shefali madam, who had been very kind in coordinating all the efforts, right? And also it's a privilege for me to actually address the students and faculties. And I really enjoyed speaking to all of you about cloud computing, and it's a very interesting field. So I would like to thank all of you for participating, patiently waiting for half an hour more than the duration, and I wish you all the best. Thank you so much.
Thank you, sir. Audience, please fill the feedback form. It's already shared. I would like to thank our management, Mr. Rajiv Kauda sir and Mr. their consistent support in our growth. I would also for always encouraging us to reskill ourselves. Many thanks to Professor Kemparaju N, HOD department, who is a strong pillar of the department. Thank you, sir, for always motivating us and empowering us. And along with this, we are thankful to all the participants who joined from various states. Thank you so much, everyone. The Buddha words, there is no wealth like knowledge and no poverty like ignorance. With this session, with this, we are going to end the session. Thank you so much, everyone. Have a nice day.
Thank you. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you. Thank you for coming and accepting our invitation.
Thank you so much. Yeah, it was a pleasure and it was a privilege. Thank you so much.
Okay.
Thank you, everyone.